what we're going to be talking about today is a different way of taking an equation and using a different method to figure out what the line is going to look like. All right, so when we have an equation that looks like this, 3x plus 2y equals 6, it's not written as a function because, can anybody tell me why this equation, the way it's written, is not a function? So this is not a function the way it's written here because a function is y equals something. So it has a variable by itself. Remember when we wrote it in function notation, it was f of x equals something, or h of x equals something, or y of x equals something. So when we write a function, we have to have a variable by itself on one side. So in this equation right here, there is no variable that's by itself on one side, so it's not in what we call a function form. All right, that doesn't mean, though, that we can't draw a picture of this equation in the coordinate plane. So we can still, since we have x's and y's in the equation, we can still find some ordered pairs that are on this line and plot those ordered pairs and see what the equation is going to look like in the coordinate plane. So what we're going to do is we're going to pick two special points, and we'll talk more about what these points are called later. But what I want to do right now is I want to find the value of x when y equals 0. All right, that's part A. So let's do that right now. So I want to find, for part A, I want to find the value of x when y equals 0. So I'm going to start just by writing y equals 0 here, because that's the thing that I know. And I'm going to start with that to figure out what x is. So what do you think I'm going to do with that 0 in this equation? I'm going to plug it into the equation. So I'm going to rewrite that equation. So we've got 3x plus 2. Now instead of y, what am I going to put? 0 equals 6. All right, so we just rewrote this equation here, but when we rewrote it, we changed the y into a 0 because we know y equals 0. Now the question is, what is x? So next thing I'm going to do is solve for x. So when we're solving an equation, what do we do to start? It's the first thing we do when we're solving an equation. All right, so we circle the variable, the x, which we want to get by itself, and we draw the line of equality. All right, now I want to get that x by itself. One thing that I might do here, instead of the 2 times 0, I'll rewrite it. And instead of 2 times 0, I'm going to put what? 0, right? 2 times 0 is 0. So I'm going to rewrite this with a 0 in there. So we have 3x plus 0 equals 6. And do I need to subtract 0 to get rid of the 0? No, why not?
There's nothing to do.
Yeah, if you add 0, it doesn't change anything. So really, 3x plus 0 is 3x. So even though I changed it to 0, I'm just going to scratch it out and pretend like it's not there. There's only really one thing that I need to do now to get x by itself, which is what?
Divide.
Divide. Divide by what?
3.
3. So we're going to divide by 3 on each side. And when we divide by 3, what do we get on the left side?
2.
On the left side?
X.
X. And on the right side, 6 divided by 3 is 2. Now, there's one more thing that we need to do here. The problem says find the value of x when y equals 0, but it says write your answers as ordered pairs. So how could I write this 2 here, as an ordered pair? So really, 2 is not the only part of our answer. So we have x equals 2, but we also know that y equals 0. So we can use the x and the y value together to write an ordered pair. When we write an ordered pair, which one always comes first?
X.
The x always comes first. So when we write the ordered pair, I'm going to do it off to the side. You probably have more space than I do. When we write the ordered pair, x equals 2, so we put that first, and y equals 0, so we put that second. And that's the answer that we're looking for, so that's the one you want to put a box around. Notice that I didn't box this, but I boxed the ordered pair because that's the answer that we're looking for. Does that make sense? Mm-hmm. All right, so let's do the same thing now, but for the x values. All right, so we know that x equals 0 for part B. So I'm going to start by writing x equals 0. And then what am I going to do with that 0? What's that? We're going to put the 0 in where the x was. So when y equals 0, we put 0 in where the y was. Now x equals 0, so we're going to put 0 in where the x is. So we're going to have 3 times 0 plus 2y equals 6. And this time I'm going to take a little bit of a shortcut. So let's look at what happened over here real quick. When I did 2 times 0 is what?
0.
It was 0. And so we ended up just scratching that out, right? So let's just do that from the very beginning. 3 times 0 is going to be 0, and then 0 plus 2y is just 2y. So from the very beginning, what I'm going to do is I'm just going to get rid of the part with the 3 times 0. I'm going to scratch that out. So really all we have is 2y equals 6. All right, so how do I solve for y?
Circle y and line of equality.
Circle the y, draw the line of equality, and then there's only one thing I have to do to get y by itself. Divide by 2. So we'll divide each side by 2. And when we do that, the 2's cancel, leaves y equals 3. And again, we want to write our answer as an ordered pair. So we have y equals 3. Is that going to go first or second in our ordered pair?
Second.
That's going to go second because y always comes second. What's going to go first?
0.
The 0, because remember x equals 0. So the ordered pair here is 0, 3. So notice that for this one equation, just by plugging zeros in for x and y, we got 2 different ordered pairs. And we could take both of those ordered pairs and plot them in the coordinate plane if we wanted. All right. Now, does anybody know why we would choose 0 here? Why is 0 a good number to use when we're doing something like this, Carl?
Because you're not too really on the plot thing, the graph thing.
Okay, so one thing is, when you're graphing it, one direction you're not going to have to move. You're either going to be on the x-axis or on the y-axis. All right, so that's one good reason. What about solving the equation? What did putting 0 in do for us that made things easy when we're solving the equation?
You didn't have to do as much.
Yeah, we didn't have to do as much. So when we put 0 in here, then we had a 0 and we multiplied it and we just scratched it out. It disappears. Same thing here. When we put 0 in, we can just ignore that. So it saves us a step when we're solving the equation by putting 0 in. If we put a number in that wasn't 0, if we put like 1 in here, then we would have a 3 that we would have to subtract, and then we would have to divide by 2, and so it would be an extra step. So 0 makes things easier in a couple of different ways. It makes solving the equation easier. It makes plotting the points easier. All right, so you're going to do the same thing. Find the value of x when y equals 0. Find the value of y when x equals 0. Write your answers as ordered pairs. Be sure that you're starting with writing y equals 0. Start with writing x equals 0, and then solve. All right, so let's go ahead and get started here. What I'm going to do is I'm going to do both sides kind of at the same time just so we can see what's happening at each step on each side. So for the first one, for part A, we have y equals 0. So we're always going to start by writing what is equal to 0. That way we don't forget and get confused later on. And then the second one, x equals 0. So substituting in the first one, we're going to rewrite the equation as 2x minus 4 times 0 equals 12. And in the second one, we're putting 0 in for x, so it's going to be 2 times 0 minus 4y equals 12. And the next step in both of these, we're going to need to solve the equation, but solving the equation is a little simpler than what it actually looks like because part of these equations are going to go away. So in the first equation here, what's going to go away?
4.
Well, the 4 times 0, right? So what I'm going to do right off the bat is I'm going to scratch out the part with the 0 in it. And notice that I also scratched out the negative because that negative goes with the 4, right? So negative 4 times 0 is 0. 2x plus 0 is 2x, so we're just going to get rid of that part. In the second one, which one are we going to get rid of?
2.
The 2 times 0. Should I get rid of the negative also?
No.
No, this negative here needs to stay because that goes with the 4y. So we're going to scratch out the 2 times 0, and we're left with negative 4y equals 12. All right, so now we're going to solve. I always start by circling the variable and drawing the line. Now again, by using 0, it made things easy for us because all I have to do now is get rid of the The 2. I want to get x by itself, so I have to get rid of the 2. And how am I going to do that? Divide by 2. So I divide by 2 on each side. On the left side, those 2's cancel each other out, leaving x. On the right side, 12 divided by 2 is 6. Now, that's not my answer. I want to write my answer as an ordered pair. So what is the ordered pair going to look like?
6, 0.
Yeah, and why does the 6 come first? Because that's the x value. So that's the answer that we want to put a box around. We have 6 is x, 0 is y, and so we get our ordered pair for that one. Over on the other side, I want to solve for y this time. So I'm going to circle that y and draw the line of equality. And to get rid of the negative 4, what am I going to have to do? Add 4? No, it's negative 4 times y, so we have to divide by... Are we dividing by 4 or negative 4?
Negative 4.
Yeah, I got to divide by negative 4 on both sides. So those negative 4's cancel each other out. That leaves y all by itself. And a positive 12 divided by a negative 4 is negative 3. All right, and again, that's not our answer yet. It's just going to help us write our answer. What comes first? 0. So x comes first. We know that was 0. So that's why we write it down up here, so we remember that x is 0 and y is negative 3. So again, with this equation right here, even though it's not in function form, function notation, we can quickly find 2 ordered pairs on it by plugging 0 in for x and plugging 0 in for y. All right, what could we do with these ordered pairs if we wanted to? We could plot them, right? So notice that one of them has a 0 for x, so another one has 0 for y. And so as Carl mentioned earlier, these are both going to be on an axis. One's going to be on the x-axis, one's going to be on the y-axis. All right, so the next few examples, what I want to do is I want to look at problems where we're using this idea, but we're going to use it from the graph. And what we're using is something called intercepts. Has anybody ever heard this term, intercept? So an intercept in math, in the coordinate plane, is just where something crosses something else. In this case, what we're looking at is where a line crosses either the x-axis or the y-axis. So we have to remember this is the y-axis. So if a line crosses the y-axis, the place that it crosses the y-axis we call the y-intercept. So if I put a line up here, what would you say is the y-intercept of this line? Sorry, let me fix it real quick. What's the y-intercept of the line right there? Okay, Libby said 2. Why is it 2, Libby?
Because that's where 2 line.
Yeah, so if you look at where the line crosses the y-axis, it crosses where y equals 2. So we would say the y-intercept equals 2. Now, can anybody tell me what the ordered pair is for that line? For that point, sorry? This point right here, what's the ordered pair? 0, comma, 2. So what's familiar about the way this ordered pair is written? What does it have in it that some of the other ordered pairs we've just written has in it? Has a 0 in it, right? So the y-intercept has a 0 where... Which one's 0, x or y? X is 0. So when x is 0, we get what's called a y-intercept. All right. On the other hand, when we have the x-intercept, what's the ordered pair for this one? 3 for the x-coordinate and 0 for the y-coordinate. So for an x-intercept, the y-coordinate is going to be 0. All right. So an intercept is just where a line crosses an axis. And we say that the intercept is positive 2 here. It's positive 3 here. So when we're talking about intercepts, we can just give the number where it crosses the axis. All right, so first example looks like this. On your paper, it asks you to write down the x and y intercept of each of the following and write your answer as an ordered pair. All right, so let's do this together for the first one, and then you can do the other two on your own. Where this line crosses the y-axis is called the y-intercept. So what is the ordered pair that goes with that y-intercept right there?
0, 1.
0, comma 1. So again, the y-intercept has 0 in the x-coordinate. And then the ordered pair for the x-intercept is going to be what? 2, comma 0. So the x the x-intercept has a 0 in the y-coordinate. All right, so go ahead and do the same thing for the other two examples. Shouldn't take you too long. All right, so in this example here, let's do the y-intercept first. So the y-intercept is where it crosses the y-axis. What is the ordered pair for that one? 0, 3, and don't forget the parentheses with that. And then the x-intercept is where it crosses the x-axis, and what's the ordered pair for that one? -2, 0. So we're at -2 on the x-axis, so -2 goes in the x-coordinate, and then at 0 along the y-axis. All right, how about this one? What is the y-intercept? That would be where it crosses the y-axis here. So that -3, does that go first or second?
Second.
It goes second. Why does it go second? Because it's -3 on the y-axis, right? So the -3 goes second because it's on the y-axis, which means that the x-coordinate is 0. And then for the other one, where does that 1 go? Does the 1 go first or second?
First.
It goes first because it's 1 on the x-axis, and then the y-coordinate's going to be 0. All right, so again, I want to really stress this. Notice that every time we have an intercept, one of the coordinates is always 0. All right, so it may seem a little bit backwards, but when you have a y-intercept, then the x-coordinate is 0. When you have an x-intercept, then the y-coordinate is 0. And the reason that is because when we have a y-intercept, it's the y value that really matters. All right, so when we have a y-intercept, that's the one that's not going to be 0. All right, so a couple of things here, just to summarize what we've said so far. Intercepts are where a line crosses what? An axis. There are two axes, right? There's an x-axis and a y-axis. So the x-intercept is where the line crosses the x-axis. And let's go ahead and fill in the other blank before we answer those questions. The y-intercept is where the line crosses the y-axis. All right, so then there's two questions there, so you don't want to flip your paper over yet. First question is, what will always be true for the x-intercept? So the x-intercept is where the line crosses the x-axis. So we said one of the coordinates is always 0. Which coordinate's always going to be 0? For the x-intercept. Is x going to be 0 or is y going to be 0? Y is going to be 0. So for the x-intercept, y is always equal to 0. All right, so you might put that in there. The other thing I would do, if I were you, is write something like this. So for the x-intercept, it's always going to be something, 0. So we don't know what this is. I'll put maybe a question mark there. So it's always going to be something, 0 for the x-intercept. So for the y-intercept, what's always going to be true? For the other one. For the y-intercept, x is always going to equal 0, which means that the ordered pair is going to be 0, something. And we don't know what that something is until we solve for it. All right, so in the last few examples that we did, we gave you a picture of what a line looks like, and you figured out what the intercepts are. Now we're going to do it the other way. We're going to give you the intercepts, and you're going to figure out what the picture is going to look like. All right, so for example 6, and I want to be clear about this. Example 6, example 7, example 8, we're going to do all of those on the same coordinate plane. All right, so in example 6, we know the x-intercept equals 3, and we know the y-intercept equals -4. All right, so make sure you get that negative in there. It's kind of hard to see it here, but the y-intercept is -4. So what are we going to do to figure out what this line is going to look like? Line A. Taylor? Okay, so we're going to plot a point that goes with the x-intercept. So since it's the x-intercept, we're going to be on the x-axis. In fact, we should probably start by labeling the x-axis and the y-axis. And so for an x-intercept of 3, where's that going to be, Taylor? Which way is that? We're going to go right 3, right? So on the x-axis, we find the 3, which is going to be right 3, and we put a point right there. And then for the y-intercept, we're going to go which way? Yeah, so we're going to be on the y-axis. So we go on the y-axis and go down 4 from the origin. and we get a point right there. And with those 2 points, what can we draw? We can draw a line, right? So remember our 3 rules for drawing lines. What are they? Got to be straight, so use a straight edge. What else? Got to go through the points. In fact, not just through the points. All right, we don't want to just do this, but we want to go, well, this is past the points. What else do I want to do, though? I want to go all the way to the edge of the grid. All right, so I'm gonna start at the bottom edge of the grid and go all the way to the right edge of the grid is what's going to happen here. Let me move that so it's going through the lines. So go all the way to the edges of the grid. So we got a straight line. It goes through the points to the edge of the grid. And what else do we need? Arrows. Now, there's one more thing we're going to do before we move on to the next example. Since we're going to put 3 lines all on the same coordinate plane, how are we going to tell the lines apart? We're going to label them. So we want to label this one line A. So I like to label them at one end or the other. It doesn't really matter which end. So I'm going to label line A down here next to that line so that I can tell which one's which. All right, so make sure that you label your lines so you know which line is which. All right, so I want you to try this one on your own. For line B, we have an X-intercept of -6. Be sure you get that negative in there. And a Y-intercept of +6. All right, so if the X-intercept is -6, where's that point going to be? We're going to go, X-intercept is -6, so we go left 6, right? So your coordinate plane looks a little different than mine. Mine has more than 6 spaces, so I'm going to go over 6, and I get to right here. Yours is going to be the last one on the coordinate plane, I think, right?
Yes.
So we go left 6, and then the Y-intercept is +6, so we go up 6 on the Y-axis. Remember, Y-intercept means we're on the Y-axis, so it's going to be right here. And then what? Draw your line. Again, make sure that your line goes through the points all the way to the edges of the coordinate plane, and make sure you label your line because this is the second of 3 lines that we're going to put on this coordinate plane, so we want to put a B on that one. Okay? All right, let's do one more. So the intercepts look a little bit different here, but it's actually not any harder, is it? So all this is doing is it's just writing it as an ordered pair rather than just saying we're going through this number on the x-axis and that number on the y-axis. So we're just plotting 2 points again. All right, this time x is -3. So we'll go to -3 on the x-axis, should be left 3. And then y is -8, so we're going to go down 8 on the y-axis. And again, yours is going to look a little different because my coordinate plane is bigger than yours. But you should get a point down there. Draw your line all the way to the edges of the coordinate plane again. Put your arrows in there. And label it what?
C.